Hi, good to see you again. Welcome to Block 1, Constructing, Measuring, and Using Geometric Notation, Lesson 12. I'll share my screen. So, in your previous lesson, you learned how to identify different polygons up to decagon. In today's lesson, you're going to learn to construct triangles using SSS. SSS stands for side, side, side. Remember to like the videos, share the videos with those you think can benefit, subscribe to the channel, and click on the notification bell so that when new videos are released, you will be notified. Thank you. Before we start, I would like you to pause the video and answer the retrieval practice questions in 2 minutes. Assuming you've paused the video and you've answered the retrieval practice questions, here are the answers. Let's discuss them. So here you were asked to work out the perimeter of the triangle. Here we can see these hatch marks show that this side is equal to this side. So even though the length is not written for that side, we know that it is 9 centimeter. So the perimeter is the sum of the sum of the distance of all the sides. And that should be 23 centimeter. Next, you were asked to work out the area of the triangle. I'm sure you have not forgotten how we work out the area of a triangle. You multiply the base with the perpendicular height to the base, and then you have whatever you get. In that case, the area is half the base times the height, but the height must be the perpendicular height. So here, our answer will be 14 times 5 divided by 2, which should be 35 millimeter squared. Which classifications of triangle can also contain a right angle? By now, you should know that there are isosceles triangles and scalene. Okay, so scalene triangles are the ones where the sides are all not equal. Okay, let's do some new learning for today. Before we start, I would like you to make sure you have your ruler, have your pencil, have your compass, okay? Because we're going to be doing some construction, okay? Also have your protractor. We may not need it now, but we may need it towards the end of the lesson. So have your pencil, have your ruler, have your compass, have your protractor, and have your rubber, because you'll make mistakes undoubtedly. So you would be able to rub off those mistakes and then do the correct construction. So SSS means side, side, side. If we want to construct this triangle, the first thing we're going to do is to use a ruler and draw a length of 10 centimeter. Next, we'll take a compass, open the compass, the pair of compass, to exactly 5 centimeter. Next, we'll position the compass and draw this arc that you see here. So we'll position the compass. So let's go back. We'll position the compass that is exactly 5 centimeter and draw this arc that you see here. So exactly the way the compass is positioned, you simply move the compass to draw that arc. Next, you open your compass to be 7.8 centimeter and you position the compass on the other end and draw the other arc. What we are interested in is the point where the arcs meet. So we're going to take a ruler and join the left end of the line, of the 10 centimeter line segment to the point where the arcs meet, and we'll do the same for the 7.8 centimeter side. The last thing we do is we write the lengths in. Take note, when you're doing construction, you must not rub off the construction lines because that is what gives you the marks. That is what the examiner is interested in knowing, that you were able to do the construction correctly. Okay. Okay. Construct a triangle with side lengths 6 centimeter, 7.5 centimeter, and 10.5 centimeter. To do this, Alex said we could do it this way. Yeah, so we draw the 6 centimeter and then we, do our construction to produce that. Eva, yeah, so Alex says my diagram looks different to yours. How might Eva's diagram be different from Alex's diagram? And is a triangle different? Have a think. Well, not really. Okay. So the triangles are actually the same. Now, if you look carefully, one is simply a mirror image of the other. One is a reflection of the other. So they are the same triangles. All right, pause the video and answer questions 1 to 4, putting into practice what you've learned. So for questions 1 and 2, you ask, use a ruler and a pair of compasses to construct a triangle with side lengths of 7 centimeter, 6 centimeter, and 4 centimeter, and then discuss your method with a partner. Which side did you draw first? And then you were also asked to construct an equilateral triangle with a side length of 5 centimeter. Assuming you've paused the video and you've answered the question, here is what yours would look like. So I am going to head over to, I'm going to stop sharing. I'm going to head over to MathsPad so that we can do a little demonstration. So I will do the demonstration only for the first one, which is, in fact, I'll try to do it for both of them so that you observe how it should be done properly, and then you can have that practice too. So 7, 6, and 4. All right. So we want to construct a triangle with sides with lengths of 7, 6 by 4, 7 by 6 by 4. So I'm going to share my screen. Let's see. Let's share the desktop. Let's see what we can do with that. Okay. So we want to draw a 7 by 6 by 4. So first thing, you take your ruler, okay, and so we can move the rulers. So we want to draw 7 by 6 by 4. So we want the length to be 7 centimeter. So we put it, so 7 centimeter. Okay. We move the ruler, we take our compass. So this is 7 centimeter. So let's just write the length in to make sure. And then we take our compass and we want to have 6 centimeters. So we position our compass right there. And we open the compass to be 6 centimeter. We lock this to make sure it doesn't move. We take our compass, we put it right there, and we draw our arc. We draw our arc by holding there, and we draw our arc. Okay. Next, we need 4 centimeter. So we'll take our compass. We'll move it to the point there where we want to draw 4 centimeter. We'll unlock that. We want to measure 4 centimeter. So we lock that to make sure it doesn't move. We take our compass, we position it there. And we move. Okay. Then we hold that and we draw our arc of 4 centimeter. Move our compass out of the way. We want our ruler. Or we can just draw a line segment. A line segment should be able to do it for us. So we just take a line segment to join that point, and we take a line segment to join that point. The next thing we'll do is we label the sides. So that's 6. And that's 4 centimeter. So this was for question 1. For question 2, we were asked to draw an equilateral triangle with each of the sides being 5 centimeter. So what we'll do is we'll take our ruler again. So let's unlock that because we're going to need to get a 5 centimeter. So it doesn't matter, we can do it from here to there. So we want 5 centimeter. We'll lock that to make sure we've got it right. So let's draw the first part, which is 5 centimeter. We just need a line that is 5 centimeter. So take a pencil. We'll start from here. We want 5 centimeter. I think that's about right. We'll move the ruler out of the way. We take our compass, which is 5 centimeter. Let's remove that. We only need the compass. We put it there. Let's move it to make sure it's in the right orientation. We draw our arc. Remember, the compass has been opened to 5 centimeter, and you can see it's exactly the length of the 5 centimeter line. We move our compass to the end of the other line. Let's move this to make sure it's in the correct orientation. And then we draw the other arc. Let's move the compass out of the way. Oh, we don't need it anymore. And we can actually use our line segments to join the points we need. And you can see that we have formed an equilateral triangle. And we can actually label the sides. So it's 5 centimeter, 5 centimeter on that side, and 5 centimeter on that side. So this one is the solution that you should get for question 1 and 2. So I'll really encourage you to practice this again and again and again with your paper, pencil, compass, ruler. Have a rubber in case you make a mistake. All right. So let's get back to the lesson slide. Okay, so you saw the solution to questions number 1 and 2. Question 3 and 4, you were asked, Eva sketches an isosceles triangle. Make an accurate construction of the triangle. Use the accurate construction to work out the area of the triangle and then show the steps in your working. Then question 4, show that a triangle with sides of 3 by 4 by 5 is right angled. Well, what we're going to do is I'm going to discuss quickly the solution for this one, for A and B. To make an accurate construction, so I'm just going to explain these steps. You've already seen me demonstrate how to do the construction properly. So I'm just going to explain this one real quick. I don't want this video to be too long, okay? So step 1, you're going to draw your line, make sure it's 6 centimeter with a ruler and your pencil. Step 2, you're going to open your compass to be 5 centimeter. Place your compass here and you draw an arc. Step 3, you're going to use that same 5 centimeter mark of your compass, place it here and draw the other arc. Next, you take a ruler and join these like that, and that would form your isosceles triangle. I didn't intend it to be that long. I need to rub off the other parts so that it looks a bit decent. Just a minute. So let's get... So that's what I want. So you label your sides. So that should be 6 centimeter. That should be 5 centimeter. Put the hatch marks to show that they are the same. And that should be 5 centimeter. Next, you were asked to use the accurate construction to work out the area of the triangle. Now, remember, the area of a triangle is half times the base with the perpendicular height. So you could use, next thing, after you've done your construction, use your ruler to measure the perpendicular height from the base all the way to the top, to the vertex. And then you use the formula half times 6 times the height that you measure, okay, using your ruler. Okay, and that you see that your answer will be 12 centimeters squared. Okay. For question 4, you were asked to show that a triangle with sides of 3 by 4 by 5 centimeter is right angled. So you'll do the same thing like we do the construction. So first thing, my suggestion is first thing, draw the 4 centimeter side like that. Then open your compass to be 3 centimeter. put the compass there and draw the arc. So you will have something like this. Then open your compass to be 5 centimeter, place it in this end and draw an arc. You would have something like this. So when you finish, you're going to form something that looks like this, and that will make it a right angle. So this will be the 5 centimeter. Okay, and that will be the 3 centimeter. Mine is not exactly drawn to scale because I'm just explaining and trying to demonstrate it. There are other ones I would like to demonstrate, so I don't want to do this one so that we do not take too much time in the lesson. Okay, let's move on to a new learning. Can you always make a triangle by putting any 3 of these rods together? Have a think. Well, let's try. If we put these together, yes. If we put these together, we cannot form a triangle. Okay? Now, here is another example. Dora is constructing a triangle LMN. Dora says, I predict that the greatest interior angle will be angle LMN because it is between the 2 longest line segments. Well, let's investigate and see whether she's right. Well, if we do our construction, you would notice that if we do our construction in different ways, if we use the 7 centimeter as the base and we use the 5 centimeter at the base, we would be having different angles. Now, of course, you would notice that because just common sense, thinking about it, if the base is 10 centimeter, don't you think the longer the base gets, let's imagine we stretch it further to be 15 centimeter, don't you think this angle will get wider? I want you to pause and have a think about what I just said, because then we can agree with Dora that the longest line segment would subtend, that is the language we use, the largest angle. It's now time for you to pause the video and have a practice. So question 5, you were asked here, pause the video and answer question 5 in 3 minutes. Assuming you've paused the video and you've answered question 5, here are the answers. Let's discuss them. Question 5, you were asked, using a ruler and a pair of compass, show that Jack is correct. So Jack says you cannot construct a triangle with size 8 centimeter, 4 centimeter, and 3 centimeter. Well, if you think about it, I'm not going to use a compass to demonstrate it, but you can do that practice yourself. So if we draw, for example, 8 centimeter, if we draw 8 centimeter, let's say our base is 8 centimeter, and then we have 4 centimeter. 4 centimeter is going to be quite short. So if we do our arc is going to be somewhere here. It's not even going to go halfway. Yes, it's going to be halfway the line. Okay, it's going to be about halfway this 8 centimeter line. So let me rub this off and do another one. So I just want to show you why it's going to be right. So your arc is going to be about halfway, because remember 4 centimeter is half of 8. But the 3 centimeter will not even come close to being halfway of this line, which is 8 centimeter. So it's not even going to cut this arc. It's going to be somewhere here, close, but not even close to cutting this arc. So which means we do not have an intersection of the arcs for us to even form a triangle. All right. And I've just explained it because 3 add 4 is less than 8. Yeah, and I've explained it there. Next, you were asked, tick the triangles with measurements that are not possible. All right. These measurements are not possible for the same reason that we explained the one here. Okay. And that's the answer. Yeah. So that's the other one. Okay, for question 3. Question 5. All right. Pause video and answer questions 6 and 7 in 3 minutes. Assuming you've paused the video and you've answered the questions, here are the answers. So here you were asked, what is the size of the largest angle in a triangle with sides that measure 8 centimeter, 5.9 centimeter, and 2.4 centimeter? When you do your construction and then you use, okay, so remember what we learned, the longest side will subtend. So you're going to have this base here to be 8 centimeter because it is the side that will subtend the largest angle, because you've been asked what is the size of the largest angle in a triangle with these sides. Then you would open your compass to be 5.9 centimeter, and then you draw your arc. So that is going to go a little bit further, more than half this line. So the arc will be somewhere here. And then you open your compass to be 2.4 centimeter. And then you draw your arc. So it's going to cut it somewhere below, because remember, this arc can go as further as it can go. Okay, this arc here. So let me rub the other one off. So you put your compass for the 2.4 and you draw it. So it's going to be somewhere below, because it's a very short length. So you will see that you have a very wide angle like this. So by the time you join with line segments where they intersect, and then next, you know how to use your protractor. You use your protractor to measure this angle. You will notice that the angle is 145 degrees. So you can pause the video and take your ruler, your compass, your pencil, and your protractor and practice this to actually verify it. Then next, you were asked to construct a triangle that has a perimeter of 15 centimeter. Okay, so what you require to do there is you can compare your answer with someone else. To have a perimeter of 15 centimeter, you can have a triangle that, has different lengths, but all of them would add up to be 15 centimeter. So that is something for you to practice. And that brings us to the end of our lesson. So really well done for sticking around and for taking your learning seriously, where you have learned how to construct triangles using SSS. So side, side, side. Until next time, take really good care of yourself, and bye-bye.